The Spirit rover explored Mars for 6 years, 2 months, and 19 days before NASA lost communication with the rover in March 2010. Now more than 20 years after Spirit rover began exploring Mars, scientists have uncovered a hidden clue in its archival data that adds to mounting evidence that the red planet was once rich in liquid water. Researchers recently reanalyzed measurements collected by Spirit rover between 2004 and 2010, revealing widespread traces of crystalline hematite and altered magnetite in ordinary Martian soil, iron-bearing minerals that point to ancient chemical changes consistent with interactions between water and rock. The findings suggest liquid water may have been more widespread across Mars than scientists previously thought. Researchers combined hundreds of individual measurements from 32 undisturbed soil sites inside Gusev crater, where Spirit landed in January 2004, creating the most detailed iron mineral profile yet assembled for typical Martian soil for the analysis. Finding crystalline hematite in ordinary Martian soil was one of the most important discoveries because crystalline hematite has long been considered one of the strongest mineral indicators of past water on Mars. While it can also form through volcanic or hydrothermal activity, it commonly develops when iron-bearing rocks interact with liquid water. The discovery is particularly significant because previous analyses concluded that crystalline hematite was largely absent from Spirit's landing site. According to the researchers, the mineral's signature was simply too faint to stand out in individual rover measurements. By combining thousands of spectra collected over the mission, however, researchers were finally able to extract the important information. The researchers also identified altered magnetite, suggesting the original volcanic minerals in the Martian soil were chemically transformed over time. Together, the altered magnetite and crystalline hematite provide new evidence that water played an important role in reshaping the planet's surface, and because similar dust and soil blanket much of Mars, the findings could have implications well beyond Gusev crater, suggesting water-related chemical processes may have been more widespread across the planet than previously believed. The results thus add to a growing body of evidence that Mars was once far more habitable than it is today. During its mission, Spirit discovered water-altered rocks and minerals in the Columbia Hills, while NASA's Curiosity rover later found evidence that Gale Crater once hosted long-lived lakes. More recently, Perseverance has been exploring the remnants of an ancient river delta inside Jezero Crater, where scientists hope to determine whether the environment could once have supported microbial life. This observation shows dust and sand sliding down slopes on Mars in little avalanches. The dark slope streaks are thought to be the result of the relatively bright-colored dust avalanching down slopes, revealing the darker, coarser sand underneath. This image is the latest in a sequence of images of this crater that started in 2013. The goal is to watch the dusty slopes and try to understand more about the processes that drive these little avalanches. This animation shows this sequence of images taken over 7 Earth years, about 3.5 Mars years, and shows where new streaks have occurred on the slopes of this crater. The shape of the crater's rim appears to wobble because the spacecraft looks at the crater from slightly different directions. This observation shows some faint traces of dark flows along the head wall of an impact crater. These are relics of seasonal recurring slope lineae that formed on an equator-facing slope. They are not expected to be active yet, so NASA scientists will have to wait until later in the Martian spring for any changes. However, scientists like to monitor these sites as they progress through the seasons, and fully formed recurring slope lineae have been identified at this site before. That's because recurring slope lineae recur each Mars year at the same places, like this crater wall. Recurring slope lineae activity often happens at predicted temperatures approaching -20 degrees Celsius or -4 degrees Fahrenheit. An intermittent flow of brines is possible, but dry flow of granules is an alternative explanation to explain recurring slope lineae formation. Because of this uncertainty, the science community is debating whether these regions should be regarded as special regions, where rovers or other landers are restricted.